Have you ever pondered the invisible dance of molecules that orchestrates the symphony of life itself? The story we're about to explore today is one of discovery, innovation, and understanding that has forever changed our perspective on the microscopic world of molecular modeling. In the heart of this tale is a group of scientists, their relentless curiosity, and the groundbreaking revelation of receptors' biophysical states. Receptors, the microscopic sentinels of our cells, exist in two states, active and inactive. These states function like a switch, turning a receptor on or off through an electrostatic switch that is pH dependent. Imagine a light switch, but for the life processes within our bodies. The active state is often depicted molecular motions in visual representations. This state, however, isn't just an on-off switch. It's a chemical balance that is more akin to a delicate balance in horizontal equilibrium. Now, balances and equilibrium might conjure up memories of high school physics, but bear with me. This balance is key to understanding how receptors function. When a drug-binding molecule labeled interacts with a receptor, it tips the chemical equilibrium, altering the receptor equilibrium states. This led to the introduction of mathematical equations that mirror this balanced equilibrium and its complex interactions. But how do we measure this shift in a simple balance or a chemical equilibrium? Enter the concept of net shift or delta RH. This concept was derived using Langmuir expressions for chemical binding. In simpler terms, it's a way to measure how much the balance or equilibrium has been tipped by the binding molecule. This equation beautifully fits classical dose-response curves for receptors, signifying the efficacy of molecules. In other words, it helps us understand how effective a drug will be at eliciting a response from a receptor. And so, this brings us to the end of our story, but the start of countless others. The discovery of the net shift model in describing receptor responses has opened up new avenues of understanding, not only for the biochemistry of life, but also for the broader chemistries of the universe as described in our new book, Origins of Life Sensoria, available on Amazon. These revelations remind us that we are all part of a complex, beautiful dance of molecules, from the receptors in our cells to the farthest reaches of the cosmos. A dance that continues to inspire, challenge, and elicit wonder from those brave enough to question and explore. And while our understanding of this dance has grown, so too have the questions. New mysteries to solve, new stories to tell, and new discoveries to make. Because after all, isn't that the true beauty of science?